Okay, here's number 7. Let's see, and we haven't looked at a computer printout. I'm going to be giving you a whole bunch of printouts in a few weeks. Um, the computer printouts of these tests, so because you got to know how to read the computer printouts as well as write them up like we've been doing. So we got values of labor force participation rate of women, the LFPR, which I'm sure you guys are all familiar with, right? Are published by the U.S. Bureau of Labor Statistics. We're interested in whether there was a difference between female participation in 68 and 72, a time of rapid change for women. We checked the LFPR values for 19 randomly selected cities in 68 and 72, and we got a software output for this. Okay, so you have to look at this closely. Let's do this one first. This is a two-sample t-test of mu1 minus mu2. And H0 is mu1 minus mu2 is 0. HA, I'm reading right here, is mu1 minus mu2 is different from 0. They're different. And the test is written right in here. It says we did the average women that participated in 72 minus 68. Okay, so my two sample t-test, so mu1 is the, let's see, the rate, what do we want to call this here? The LFPR for 72. And mu2 is a LFPR in 68. Okay, and we found the difference between the means was 0.033, the t-statistics was 1.496, and there's our p-value. So by looking at this, p is 14%. So here I would say I don't have evidence for HA. Right? So this is no evidence for HA. Right? I'm just talking, I'm not writing anything up officially, I'm just talking about this. Now the next one up here, I want to make it thicker than that, but I don't know how. There we go, look at that. Okay, so we're going to do the paired t-test. This is mu1 minus 2. Okay, so now I'm taking, I'm doing this is a paired test. So I'm taking the average of the differences between the data versus it being equal to 0, meaning there's no difference, and then the average of the differences is there is a difference. I get the mean difference, I get the t-statistic, and my p-value is 0.02. So here this says I have, this is evidence for HA, and HA is, they're different. Down here, HA is, well, in both cases they're different, but this one says I don't have evidence, this one says I do. And I'm making a point of this to say that it makes a big difference which test you use, because you have to do the correct test. So here's my question. Is the data from 68 related to the data from 72? What do you think? Okay, yes, it's groups of women, it's women, but are they somehow related, like a before and after, a then and now, using the same groups of people? Now, I could possibly argue if you use the same groups of people, then they're going to be paired and you can match them together. But we randomly selected cities for 68 and 72, and we just looked at the percentages of those cities. Okay, are those two independent samples of each other? In other words, is one going to be related to the other? Oops, sorry about that. I guess when I leave for 5 minutes, to you it's like a split second since I paused it. Anyway, we'll get used to this video thing going on here. Okay, so let's go back to this. I just briefly said a bunch of things about, is the data paired or not? Are they related or not? And if I took 19 randomly selected cities for 68 and 19 different randomly selected cities for 72, then I would say, yeah, they're independent of each other. But think about what we've got here. We've got 68 and 72, and I've got city number 1. If they're the same city for each of them, which I think is the way that they mean it to read, okay, then I'm going to have a certain percent women in the labor force for 68 and another percent in 72. For city 2, I'll have a percent in 68 and a different percent in 72. So would you expect these two to be related to each other? They're in the same city. And I think it's reasonable to say yes, okay? Because in one city, if you have a higher percent of women working in 68, you're probably going to have a higher in 72, and vice versa. Okay, lower in 68, lower in 72. So it does make it is a reasonable argument to say, oh yeah, let's look at the differences. Let's look at 72 minus 68 data. And then if I look at those differences, I'm going to have one set of data to examine. And if I do that, then certainly the p-value was 0.2. 0.0244, which is less than 5%, 0.05. So do I have evidence for HA? The answer is yes. So in this case, I have evidence that the average difference between the percents of the cities in the 2 years is different. I'll let that one go on this.